Okay, we're doing 5.3, and it is solving trig equations. And I don't know if you noticed, but we're only doing 5.1, 5.2, and 5.3 of this chapter, and then your test will be on Friday. I've attached the review, even though I tried to give you guys each a review yesterday. And I have the lesson problems and my answer key all attached. And of course, you can ask me questions whenever. But it's not too bad. You do have to have your unit circle handy. And of course, I didn't bring my unit circle with me, so I'm going to have to keep flashing back and forth from the PowerPoint to my unit circle, but we'll make do. Okay, so here is the first one. And what we're going to do is we are going to solve. So we want to get the cosine terms on one side. And if you think about it, it's the same thing as saying like 5x equals 3x. This is one whole term and this is one whole term. So what we can do is we can subtract 3 cosine x from both sides, which gives us 2 cosine x equals the square root of 3. And then we're going to want to divide by 2. So I have cosine x equals the square root of 3 over 2. So what we're going to do is grab my unit circle and find cosine, which is blue, whenever it's the square root of 3 over 2. So I have one here at pi over 6, and I have one here at 11 pi over 6. So x equals pi over 6 and 11 pi over 6. Now, cosine and sine have a period of 2 pi. So these answers are going to occur every 2 pi. So you don't have to write this, but in my answer key I have, you would say that it's each of these plus 2 pi n, or as they write it, 2n pi. That just means every 2 pi for an integer of n, it'll do it again. It's just going to be a whole nother rotation. But this is the part I'm interested in you being able to find. Okay, so you can go ahead and pause it and try to do this one if you want. I'm going to go ahead and show it real quick if I can. So I'm going to add sine x to this side, so I have 2 sine x, and I'm going to subtract square root of 2, so I have negative square root of 2, and then I'm going to divide by 2, so I have sine of x equals negative square root of 2 over 2, and then I'll go to my unit circle and find the red negative square root of 2 over 2, which looks like 7 pi over 4 and 5 pi over 4, which is what they got as well. So this one is 3 tan squared x minus 4 equals negative 3. So I'm going to just start by getting rid of that 4 because we want to get this term as by itself as we can. So then I have 3 tan squared x equals 1. And then I'm going to divide by 3. Whoopsies, just ignore that. So I have tan squared x equals 1/3. And of course, I need to take the square root of both sides. So what I have is tan x equals plus or minus 1, because the square root of 1 is 1, over the square root of 3. And I need to rationalize that denominator. So I'll multiply by square root of 3 on top and bottom. So I have positive and negative square root of 3 over 3. Now tangent is has a period of just 0 to pi. So when we look on the unit circle, we are just looking in the top half of this circle. Okay, so we needed negative square root of 2 over, wait, what did I say it was? Negative square root of 3 over 3 and positive square root of 3 over 3. So since we're dealing with tangent, I wrote my tangents in green here, and I think you all wrote those on your own unit circles. If you don't have it with, then you can copy mine down. But it looks like it's going to be pi over 6 and 5 pi over 6. There we go. And then again, because the period of tangent is just 1 pi, we would just do this. But you don't have to. Okay, so you can pause this and try it, and I will do it over here. So I'm going to add 15 and divide by 5. So I have tangent squared x equals 3. And then I'm going to take the square root of both sides. So I have tangent to x equals the positive and the negative square root 3. I'll go to my unit circle, and it looks like it is 2 pi over 3 and pi over 3. And that is what they got. So this one, it looks a little more confusing. It has sines and cosines in it. What we're going to do is we're going to get it equal to 0. So I'm going to subtract the square root of 3 sine x from both sides. So it looks like 2 sine x cosine x minus square root 3 sine x equals 0. And now we can factor out the GCF. And the GCF is just sine x. So I'm going to take out a sine x. And I'm left with 2 cosine x minus the square root of 3. And that's equal to 0. So using the zero product property, I'm going to put sine of x equal to 0. And then I'm going to put 2 cosine x minus the square root of 3 equal to 0. This one's already solved. And this one I'm going to add the square root of 3 and divide by 2. So I have cosine x equals square root of 3 over 2. So now we're looking for a couple different things. We're going to look for sine of x is 0 and cosine of x is square root of 3 over 2. So cosine square root of 3 over 2, it looks like it is pi over 3 and 2 pi over 3. And then, wait, I forgot. Oh, that's cosine. So I'm lying to you. So cosine square root of 3 over 3, square root of 3 over 2. Wow, it must be late. Is going to be pi over 6 and 11 pi over 6. And then sine of x was equal to 0. So sine of x is equal to 0 when x is 0 and when it's pi. So we have 0 pi over 6 and 11 pi over 6. get the answer. Make sure I did that all completely right. Yep, 0 pi, pi over 6, and 11 pi over 6. Now, if you notice, I didn't really mention it, but since they just say on the interval of 0 and 2 pi, we only had to include those. You don't have to write the plus 2n pi after that. Okay, this one, and you do have a couple of these, I think, on your assignment. This one's actually in quadratic form, if you can see. And it doesn't hurt if we use u substitution to do this. If I say u is equal to sine of x, then I can rewrite this as 2u squared plus u minus 1 is equal to 0. And then I can solve it just like a quadratic. So I'd probably use the swing method and swing that 2 over to the negative 1. I'll have u squared plus u minus 2, and then I equals 0. And then I can factor this into two binomials. I would say it's u plus 2 and u minus 1. And since I use the swing method, I must also divide by 2. So this is going to be u plus 1, but instead of u, I'm going to write tangent, or I mean sine. So I'm going to substitute sine x back in for u. So sine x equals negative 1, because sine x plus 1 equals 0. And then I'm going to have sine x equals a positive 1/2. So I'm going to look and see where sine is 1/2 and where sine is negative 1. So negative 1 would be at 3 pi over 2, and 1/2 would be at 5 pi over 6 and pi over 6. So 3 pi over 2, and then we have pi over 6, and 5 pi over 6. So that would be my answers. Okay, here's another one. This one's a little bit trickier, so I'll just tell you, I would use u equals tangent squared. Okay, so that's going to be maybe one more step or so. But if you would like to try it on your own, go ahead. I will try to do it right here. So if I substitute u in for tangent squared, I have 2u squared minus u minus 15 equals 0. I will use the swing method and go u squared minus u minus 30. I'm going to factor that into u minus 6 and u plus 5, and then I'll divide by 2. So I have tangent squared x equals, and 6 divided by 2 is 3, and I have tangent squared x equals a negative 5 over 2. So when we take the square root of both sides, you're going to get that x, or tangent x, I should write, equals positive or negative square root of 3. And on this one, we won't get a real number if we take the square root of a negative number. So this is just an extraneous solution. So really, when we're going to our unit circle, we're just looking for positive and negative square root of 3 for tangent. So in my green, I've got this one, which would be pi over 3, and this one, which would be 2 pi over 3, which is what they get. Okay, that's, I think, all I'm going to do with you. And there's not too many problems but we will get, I'll throw the key up there and let me know if you have questions.